Hey, tech trailblazers! Welcome back to Bazai, your ultimate tech hub. The foundation, Kubernetes core concepts. Kubernetes is an open-source platform for automating containerized workloads. A cluster is your Kubernetes environment made up of nodes, think worker nodes running your apps, and a control plane managing everything. Within nodes, pods are the smallest deployable units, hosting containers. The control plane with components like the API server and scheduler orchestrates it all, while worker nodes execute your workloads. Master these basics to understand Kubernetes architecture. Next, tackle workloads and controllers. Pods run your containers, but replica sets ensure the desired number of pod replicas are always running. Deployments manage replica sets for stateless apps, while stateful sets handle stateful apps like databases. Jobs and cron jobs run one-off or scheduled tasks. Use labels and selectors to organize resources and leverage autoscalers, like Horizontal Pod Autoscaler, HPA, for pod scaling, Vertical Pod Autoscaler, VPA, for resource tuning, and Cluster Autoscaler for node scaling, to optimize performance dynamically. Now let's talk networking. Kubernetes uses a cluster networking model where every pod gets a unique IP. Services like Cluster IP expose pods internally, Node port opens external ports, and load balancer integrates with cloud providers. Ingress manages external HTTP traffic with routing rules, while network policies enforce pod-level security. DNS-based service discovery ensures seamless communication, making your cluster a well-oiled networking machine. Storage and configuration are next. Volumes provide pod-level storage, while persistent volumes, PVs, and persistent volume claims, PVCs, manage long-term storage. Storage classes define storage types like SSD or HDD. Config maps and secrets handle configuration data and sensitive info like API keys. For stateful apps, these tools ensure data persistence, keeping your databases or caches running smoothly across pod restarts. Security is critical. Role-based access control, RBAC, defines permissions, while service accounts authenticate workloads. Secrets management secures sensitive data, and admission controllers enforce policies. Pod security policies restrict pod behavior, and TLS with API access ensures encrypted communication. These layers lock down your cluster, keeping it safe from unauthorized access or vulnerabilities. Finally, master the ecosystem. Use kubectl to interact with your cluster and YAML files to define resources. Helm charts simplify app deployments, while CI/CD integration and GitOps, like with Argo CD or Flux, streamline workflows. Monitoring and logging, plus managed services like EKS, GKE, or AKS, help you scale and observe your cluster like a pro.